Howdy folks, welcome to Module 7 of the CompTIA A Plus course. As you can see, this is based on the new 1200 series of A Plus, and today's module is about supporting network services. Now, as for the main sections of this specific module, it consists of 3 sections, folks. The first section we're going to be diving into is called Services Provided by Network Hosts. Then we'll move into Internet and Embedded Appliances. And then lastly, folks, we'll move into the section called Troubleshoot Networks. Now, like usual, folks, this is obviously not a full list of what's going to be in this specific module. If you'd like a more accurate list of what can be found in this module, you can find that in the video description down below with some nice convenient timestamps if you want to jump ahead to specific topics. Alright folks, and then before we jump into that first main section, if you haven't done it already, show this channel some support, give the video a like, it does help me, it helps the video, helps the channel, man, it's always appreciated. And then of course, if you'd like to know when Module 8 comes out, or any of my other content, then maybe consider subscribing. Speaking of other content, at the end of this playlist, you will find some practice questions for the A+, for both Core 1 and Core 2. So just keep an eye out for those. There will be multiple practice questions videos coming out specifically for the 1200 series of A+. And if you want additional content over and above that, you can find that on my Patreon, guys. So feel free to go check out my Patreon. The link is in the video description down below. Anyway, folks, let's move you into that first main section. Services provided by networked hosts. The first topic I've got in this section for you guys is web servers. Good old-fashioned web servers. If you don't know what a web server is, guys, in a nutshell, that is a server that basically hosts a website for you or for somebody else. Now, many moons ago, you would generally find most of these servers on premises. So if you or your company had a website, that server would most likely be on premises, and that's where it would be hosted. It'll probably be your responsibility or somebody at your company to go and maintain this server, make sure it's up to date, make sure it's secure. If something goes wrong or something breaks, it will be your responsibility. Nowadays, however, things has obviously changed. Times change. So it's actually very common to find companies, just having their website hosted on some other you get a lot of web hosting companies out there. Obviously you can go and make use of Microsoft, go look at something like Microsoft Azure. Alternatively, there are many web hosting companies out there that will host your website for you. Depending on what they charge you, some of them may or may not make the site for you. Sometimes they'll go and develop it for you and they'll host it for you. Other times they will just host it for you and you're going to have to go and get your own developer. Unless you happen to have a developer or you happen to be one, that could obviously save you some costs if you've got an in-house developer. Now, these web servers, folks, whether they are on premises or otherwise, they're normally going to be hosting websites, but these days it's actually quite common to also find them hosting web applications. And in a lot of cases, you'll find that these web applications are basically like software as a service. So instead of just hosting your traditional website, where you'll just browse the website and do whatever it is you do on websites, web applications sometimes at first appear like a normal website, but it's actually an application running online. It allows you to do all kinds of various things. Now, web servers is normally what's going to be hosting this in the background. But you might also find that these web applications sometimes are way more complex and there might be additional fees involved. Now, folks, when it comes to browsing the internet, what protocol do we normally use? That would be HTTP. Make sure you remember that for the exam, guys. You do need to be familiar with the protocols and you do need to know what port numbers they use. So the normal protocol we use for normal web browsing is HTTP, which is short for Hypertext Transfer Protocol. And the port number normally associated to that we normally go do clear text web browsing in, would be port 80. Now, HTTP, folks, like I just said, is clear text web browsing. That means it's unsecure. It means if someone or something is in between you and this website, they could potentially capture that traffic with a packet sniffer or something, and they could potentially get something of value. A username, a password, a bank account number, a credit card number, So these are obviously huge concerns, which is why you'll find nowadays it's way more common to find websites using what we call HTTPS, which is an encrypted version of web browsing. Now, getting back to HTTP, the clear text version, the unsecure version, a lot of people might not notice, but it actually has a secondary port, which we call an alternative port number. And that, folks, is port 8080. Watch out for that because they sometimes catch people of that in the exam. Not everybody realizes that HTTP actually has two port numbers, the main one being 80 and the secondary one being 8080. Now, getting to the HTTPS we spoke of earlier, that is obviously the secure version of web browsing. It's an encrypted version of web browsing. Now, don't get me wrong, it's not the most secure web browsing out there, but it's definitely a heck of a lot more secure than your normal HTTP. So the S at the back simply just stands for secure, which means it is encrypted. The port number associated with HTTPS, just in case you guys don't know, is port 443. Once again, make sure you remember these protocols by their names. Make sure you know what they stand for. Make sure you remember the port numbers as well, guys. So normally we suggest you familiarize yourself with all the well-known port numbers, which are also known as common port numbers. So in general, there's over 65,000 port numbers, but you don't need to know them all for the exam. You just need to know all the well-known ones, which are also called common port numbers. This will be for things like HTTP, HTTPS, FTP, SFTP, Telnet, SSH, DNS, RDP, and the list goes on. Those basic things, if you go look at those port numbers, that is the well-known port numbers we're talking about, or the common port numbers. Anyway, folks, moving you on to the next topic in this section, Mailbox Servers. Now, fortunately for you guys, you don't have to struggle as much as some of the previous technicians used to do. So not so long ago, as recently as 10 years ago, it was quite a mission to have to go and set up a user's email inbox on their phone, their tablet, their laptop, or their desktop. You had to not just know their email address and their password, but you had to know the incoming mail server, outgoing mail server. You had to go and configure various encryption settings and security settings and all that. It's definitely not rocket science, but it does take a lot of time to get the information you need. It's especially time consuming if the client or the user themselves don't know what their settings are. Now you need to try and basically pull a rabbit out of a hat here. So not so long ago, 10, 20 years ago, guys, we made quite a lot of use of something called POP3, IMAP, and SMTP. Now, just a side note here, guys, you do need to know the port numbers for all three of those. So please go and check the port numbers for all three of those. You need to know those for the exam. Now, do we still use those three? Absolutely. We definitely still use them, but not nearly as much as we used to use them back in the day. Nowadays, it's way more common to find people using things like Gmail, Outlook, Office 365 email, and so on and so forth. Those are way more common nowadays. Now, the port numbers for those email services, the new ones I've just mentioned, funny enough, those ones are not exactly considered well-known or common, because at the time, many moons ago, when they made that list of common port numbers, they simply went and looked at what was common at the time, and it was obviously decades ago. Now, a couple of decades later, we've got a couple of things that are way more common nowadays, but since they came out afterwards, their port numbers are not considered well-known. So if you look at things like Gmail and Office 365, each and every one of them have got their own port numbers, just FYI. And I suppose we can technically go and refer to them as well-known or common port numbers, but officially, they're not. Officially, they did not exist back in the day when this official list was made. Now, folks, believe it or not, even with things like Office 365, there was a period in time where we had to go and configure almost everything manually. It was very annoying. So for me, I think it was up until about roughly 2016, 2017, somewhere around there. Up until more or less that period, I had to go and configure this manually for users, customers, and clients and stuff. Now, laptops and desktops, it wasn't too big of a deal. I could do that remotely, fairly quickly, fairly easily. So whenever it was a convenient time for the customer or the client or the user, I would just go and remote connect to their machine. And I would go and, open Outlook or whatever it is they're using, type in their details. It wouldn't take that long, get them up and running. So it wasn't that big of a problem when it came to laptops and desktops. But in terms of phones and tablets, that was a bit of a different story. We didn't always have a way or a means to go and remote connect to these devices. So if somebody wanted their work email on their phone or tablet, which believe me happened quite a few times, I had to drive out to the client. Some of these clients were like up to an hour away. So it's very frustrating to have to drive out to a client up to an hour's drive sometimes, literally just to go and configure their work email on their phone. And it takes me like 2 minutes to go and do it. They might say, but why don't you just explain to them over the phone or in an email how to go and do it themselves? Trust me, I've tried. These people are just, I don't know what the word is, but doesn't matter how you explain it, they just cannot grasp the concept. So sometimes you just need to go and do it yourself. Now, you guys are very fortunate. If you go look at things like 365 at this point in time, most of the time, you don't need to go and configure anything. You or the user, all you need to go and type in, and this actually extends to Gmail and other services as well, all you or the user need to type in is literally just the email address in most cases, along with the password. Everything else will get picked up automatically and be configured automatically. I mean, how convenient is that? So this only started happening around 2017, give or take. For some people it might have been earlier, for some later, but more or less 2017 is when I started seeing this at most of my clients. So yeah, I wish it was that easy always. Unfortunately, most of the time when I had to go and set this up, we had to go and suffer the old school way. Anyway, folks, moving you on to the next topic here. Authentication, authorization, and accounting. Now, guys, this is very commonly known as the AAA. So the AAA, obviously, that's an abbreviation for, authentication, authorization, and accounting. Now, in terms of authentication, this is to prove you are who you claim to be or what you claim to be. Most of the time, it's probably going to be a human being trying to prove their identity. So it's probably going to be a user identity, someone like you. How you do this is up to you. There's many categories you can go and use. Each category is referred to as a factor. A category could be something like a password or a PIN or a phrase you know. That is a category, or should I say, a factor. It could be something you or the user have or possess. This could be something like a bank card, smart card, access card, thumb fob, phone, because the phone receives a one-time PIN. Or it's got some sort of acknowledgement you've got to go and do on some sort of app like a Microsoft Authenticator app, the Google Authenticator app, or possibly on your bank. You'll find a lot of banks these days, if not most of them, they force you to go and authenticate on the app if you want to make some sort of payment. Now, in terms of authentication, if we're carrying on with this factors that we get, it can also be something you are, which is normally biometric in nature. So if you want a couple of examples, this could be a fingerprint scan, retina eye scan, voice recognition, facial recognition. So I've just given you guys 3 categories there of 3 factors, but there's many other ones. It could be something you're doing. It could be somewhere you are. In other words, a geographic lock. It can also be a time lock where you can only access a certain resource during certain times, certain days, certain weeks, certain months, but usually it's going to be a time lock in a sense of actual times of day. So if this company or this organization's working hours is perhaps between 8 and 5, you'll find the average person can only access company resources between 8 and 5. If they try and connect to this before 8 or after 5, well, you can guess what's going to happen. It's not going to work. So authentication in general, guys, you can think of this as step 1. Step 1 almost always takes place, but step 2, being authorization, does not always take place. It's not really referred to as step 1 and 2. It's just an easy way to think about it. So authentication, it doesn't matter what you log into these days, that's going to take place. Whether we're talking about your computer, a domain account, whether we're logging into an email account or a Facebook account, everywhere we need to prove we are who we claim to be. Authorization is to check what level of access you have once you have already been authenticated. Once you or the system or whatever it is has proven that you are what you claim to be or who you claim to be, authorization is just to check what level of access you have as that particular user or that specific device or as that specific account. Now, this does not take place everywhere all the time. If you look at something like Facebook, for crying out loud, once you've logged in, you've got full outright access. If it's your own personal laptop or desktop, assuming it's on a domain, once you've logged in, you probably have full outright access. So authorization, a good example will probably be something like a company's domain environment. Once you log in, it's going to see, oh, you are an employee. but you are only the following kind of employee. You only have the following permissions. You can only do this and you can only do that. You can only see this and only see that. Or it might say, oh, hang on a moment. You are a manager or you are an IT administrator. You can see all of the following and do all of the following. So authorization is really just to check what level of access you've got, folks. Accounting is keeping track, keeping log of everything. Now, folks, I'm not sure if you've noticed, but you probably have by now. Absolutely everything we do everywhere these days is pretty much logged. Whether you're doing something on your own phone or tablet, on your laptop or desktop, on a server, online, it doesn't matter. Everything we do is logged. And I mean, that can be both good and bad, I suppose, depending on how you look at this. So in the sense of figuring out what went wrong, so if something no longer works, you can go and use the logs to go and check, okay, you know what? When did this account or this app or this machine or this server or whatever, when did it last work and what changed before then? So if something changed, you can go and check what changed. So it could actually very well lead you to the problem if something is no longer working. Pretty cool, right? If someone is guilty. So if someone was maliciously sabotaging something, you can actually go and see in the logs who it was, where they did it from, how they did it, absolutely everything. So the AAA concepts, folks, also are used in networks to reduce the following risk. This is to reduce supplicants. It can be used to reduce the risk of network access devices. And lastly, folks, it can also be used to reduce the risk of AAA servers. So in other words, authentication, authorization, and accounting servers. All right, folks, let's move on to remote terminal access servers. Now, in a nutshell, this basically comes down to somehow remote connecting to something somewhere else. This could be something like a router. This could be something like another machine, possibly a client computer, possibly a server. Now, I don't personally agree with all the topics that falls under this umbrella, but hey, there we go. So the first thing we're going to be talking about is something called Telnet. Now, we don't see this as often as we used to, and I think the main reason for that is because of how unsecure this is. So not so many moons ago, we used to use something called Telnet, and this is a command line thing that we would normally have to go and use. So in a command line interface, in something like PuTTY, there you would go and use something called Telnet. Now that screenshot we have there on the right, guys, that is kind of sort of what PuTTY would look like. It's not the only way to get things done, but that is one of the main things I've seen folks use when it comes to using things like Telnet. So you're going to go and type in Telnet, followed by the destination machine or device's IP address or something along those lines. And if communication occurs, it's going to ask you for a username and a password to, of course, check if you are who you claim to be and to check if you're authorized to go and access this device. The problem with Telnet is, like I said earlier, it's unsecure. Why? Because it's in clear text. So Telnet, folks, is an unsecure remote terminal emulation. So it's very unsecure, and the main reason for that is because it's clear text. So if you happen to have somebody here in the middle that knows what they're doing, using a little packet sniffing or whatever, they will be able to see your username and password, or possibly even take control of your session. In terms of the port number that Telnet uses, that, folks, would be port number 23. Make sure you remember that for the exam, because you do need to know all your port numbers, as I've said before. Now, something else that also falls under this umbrella called Remote Terminal Access Servers is something called SSH. Now, this is very much the same thing as Telnet, if I'm being perfectly honest. The difference is SSH, if we were to compare this to Telnet, is just secure and encrypted, but it's pretty much the same can of worms as Telnet. So this, folks, is a secure remote terminal emulation, and in terms of the port number that this bad boy uses, it uses port number 22. Now, you need to be careful of this port number 22, guys, because SSH is, well, normally when we say port 22, the first thing that comes to mind for most people is, well, SSH. Now, SSH is not the only thing that uses port 22. Be very careful of that in terms of the exam. Sometimes there's questions in the exam where they check if you know or if you understand that port 22, yes, that it's used by SSH, but that it's also used by something called SFTP, a secure version of FTP. So be very careful of port 22, guys. So SSH, in a nutshell, pretty much the same thing as Telnet. It's just a secure encrypted version, and that's actually the more common one we use nowadays because, well, it's more secure. And then lastly, folks, still under this topic, Remote Desktop Protocol, better known as RDP for short. Now, when we just say remote desktop protocol or whatever, that is actually, believe it or not necessarily limited to good old-fashioned remote desktop. This could actually potentially also be other remote desktop programs. There's quite a few out there, third-party ones that you can go and make use of. But today, right now, I'm only going to be talking about the built-in one on Windows, which is good old-fashioned remote desktop. Now, unlike Telnet and SSH from earlier, which is a command line way of connecting to something, so normally with Telnet and SSH, it'll be in a command line interface. You need to know the commands of the interface that you are connecting to. So if you are, for instance, connecting to a Cisco router, you would need to be familiar with Cisco commands. It's not a graphical interface. Remote desktop, on the other hand, is a GUI-based host access and control interface. It's got a graphical interface, in other words, guys. You can actually see icons and you can use your mouse. So it's a heck of a lot more user-friendly in terms of, well, navigation, of course. So in a nutshell, this remote desktop allows you to go and remote connect to another client machine or another server for that matter, take full control of it. So you can use your mouse and keyboard to control that machine in any way you see fit. Generally, depending on which one we're talking about, if we're talking about normal remote desktop, it'll kick the other person off if there happens to be someone logged on. So if you're logged on onto your machine and I remote desktop into your machine, it's going to kick you out to the log on screen where you would normally type in your Windows password. It might even possibly display a message that says you've logged in from somewhere else, which is going to confuse the heck out of you, as you can imagine. I mean, why would you be logging in from somewhere else? That's just weird, right? And if you were to type your password in and log back in, it'll actually kick me out. And if I type my password, or, well, your password in remotely again, it'll kick you out again, and vice versa. Now, in terms of the port number that this uses, guys, it uses port number 3389. All right, folks, so we've reached the end of the first main section. Let me move you guys on over to the second main section in this module, which is Internet and Embedded Appliances. First topic up here is Proxy Servers. Now, what the cheese is that? That basically, guys, in simple terms, is the poor man's firewall. I know that's not the official term for it, but that's how I refer to it. So if used correctly, this could act as a firewall. It's not a very effective firewall, but still, it can act as a firewall. So you'll most commonly find these in small home office business environments, where they don't really have a proper firewall in place. They don't have the know-how, they don't have the knowledge, they don't have the budget, they don't have the skill, So in those environments, it's actually quite common to find what we call a proxy server. It doesn't mean we don't find them in large organizations. We absolutely still find them in large organizations as well, but they're most commonly used as a firewall in small business environments, or as we like to call it, SOHO, SOHO, for small office, home office environments. So what do? They manage user access from local network to the internet or websites. Like I said, it acts like a firewall. And they can apply content filtering and time restrictions. Now, the time restrictions is not something I see companies use often with regards to proxy servers. I mean, obviously you can. It's just something I don't see them using proxy servers often for. Normally, proxy servers are more often used for content filtering. So think of this as a list of commandments that you are not allowed to go and, well, disobey. Thou shalt not go and access Facebook. Thou shalt not go and access YouTube, and so on and so forth. So generally, at most company environments, you'll find that your company will prohibit the users from accessing things like social media. And this is usually because people fool around during working hours. The company's paying them to do their job, and these folks will sit on Facebook and YouTube and whatever other social media you get out there instead of doing their work. So as a result, most companies, maybe not all of them, but most companies will go and block websites like social media to force the employees to basically do their work. One of the ways they do this, folks, is to go and make use of a proxy server. It's not a very effective way, but still, it's better than having nothing. What happens, guys, here is a picture for you guys at the bottom. Normally, if you have internet, for example, at home, here you are on the left, you would have direct access to the internet, full access to the internet. In other words, you can do what you want. You can go to those not so legal websites that you all like to go to or whatever, and there's going to be nothing blocking you from doing so. In a company environment, there's normally something between you and the internet. This could be a firewall, but that's not the topic here right now, or a proxy server. So I'm going to add a proxy server here in the middle. So you've got to go through the proxy server, or at least that's the idea, for you to be able to access the internet. So a company now in this proxy server will go and configure, what websites you're allowed to go and access and which ones you're not allowed to go and access and when you're allowed to go and do so. Remember, you can also go and apply time restrictions if need be. Probably not going to do that, but you can. So that's in essence how it's going to work. So in a nutshell, you're just forcing your employees, your customers, your users to go through this proxy server. And in doing so, they obviously get blocked from accessing certain websites. Now, unfortunately, it's not as secure as some of you guys might think. There's many ways to go and bypass this. And the funny thing is, a lot of users do this purely by accident. They've got absolutely no knowledge of IT whatsoever, and they'll accidentally bypass it, and they'll be like, okay, hang on a moment. What did I just do? And they'll go and, replicate that, and they'll be able to bypass it again. They don't understand how they're doing it. They don't understand why it works. They just know that it works. And unfortunately, it just takes one person in the company to figure out that they can go and bypass it. And they'll go and tell the next person, maybe in the restroom, and the next person in the restroom will tell the next person in the kitchen. And before you know it, a day or two later, everybody's doing it, and now your proxy server is completely redundant. So one way you can bypass this proxy server, in case you're curious, is to pretend to be something you're not, to kind of hide your traffic. So if I go onto something as an example like Google Translate, Google Translate can be used to translate words, phrases, sentences, documents, or even whole websites. So if you go into Google Translate and you as an argument go and type in facebook.com or youtube.com, what's going to happen is your proxy will see this as Google Translate. Meanwhile, you're loading Facebook or YouTube inside of Google Translate. And you can fully browse and you can go use it to its full extent. Now, a lot of companies have obviously gotten clever of this. They know that you're going to do that, so they will go and block things like Google Translate or, other proxy servers and stuff. Alternatively, what you guys can also go and try and do, besides, disguising your traffic as a different kind of traffic, is to literally hide your traffic completely, like encrypting it. Now, when I say encrypt it, I don't mean anything fancy. You could literally just go and use HTTPS, Hypertext Transfer Protocol Secure. That still might sound pretty complicated, so you could literally just go and use Chrome's incognito mode, or if you're using Mozilla Firefox, you can use what they call private browsing. If you're using good old, Internet Explorer, I think Edge also calls it this, it's called in-private browsing. The point is, it forces your browser to open any web page in HTTPS instead of HTTP. HTTP is clear text, which means someone or something in the middle can see what you're doing and where you're going. Something like a proxy server. But if you browse in HTTPS, it's in encrypted session. So when you have to go for the proxy server, it can't see where you are going and what website you're accessing. It is encrypted. And since it can't see where you're going, it's just going to allow you. So that's a second way to go and bypass it. A third way would just probably be just to go and bounce yourself off another proxy server. So there's no rule that says you can't go and bounce yourself off another proxy server. That'll also work, folks. Anyway, without wasting any time, moving you on to spam gateways and unified threat management. Now, something interesting about this topic is, in many ways, this is actually the same thing, depending on the device we're talking about. This is, in some cases, actually in a lot of cases, one device, one physical device, and that would normally be the company's firewall. Any medium to large size company worth its salt would normally have at least one physical firewall. And let me tell you guys, this stuff is very complicated and very expensive. Now, in terms of the network security functions one might possibly find on some of these firewalls and what have you, keep in mind, it's not limited to firewalls. It's just usually going to be a firewall. These physical firewalls, folks, are not your traditional firewalls that'll just go and block and allow websites, block and allow URLs and IP addresses and stuff like that. No, they've got a lot more built into them. How much exactly and what exactly depends on the brand, and it depends on the model, and ultimately on the price tag. Like most things in life, the more you pay, the more you get. So network security functions, this could be a firewall. It's going to act like a normal firewall, of course. But they also have what we call intrusion detection systems built into them, which we normally call IDS. Intrusion detection systems don't necessarily do something if they detect something. It just informs you that something is going on in your network. So since everything has to go through your firewall, if your firewall sees something funky going on, something that looks very out of the ordinary, very suspicious, it'll basically log all of that, record all of it, and possibly even inform you and your IT team, but it won't actually do anything about it in most cases. If you want something to actually be done about it, that would be an IPS, intrusion prevention system. And funny enough, a lot of firewalls actually has that built into them as well. So most of these fancy firewalls has an IDS, intrusion detection system, and also intrusion prevention system. The intrusion prevention system, now that one actually does do something about it. So if it sees something funky going on, it's actually going to do something about it. The downside about that, I mean, it sounds great that it does something about it, but the downside is it can actually disrupt your network flow. So you might find yourself in a situation where the whole network is now offline because your firewall detected something suspicious and now it's just blocking everything. So that is a possibility. If you look at the intrusion detection system, which is the second point here on my list, that one, yeah, it doesn't do anything about it, but at least it doesn't stop the whole network. So your network, your information, everything in your company is still going to flow like normal. Now, in terms of network security functions, guys, this can also possibly be, and it's not limited to this, antivirus and anti-malware solutions. Could possibly be that. Could be spam gateways. These days we get spam in so many forms. It's not just your traditional email that you might receive. No. Spam can come in the form of unwanted phone calls, unwanted SMSs. Heck, these days you get a lot of unwanted WhatsApp messages. So spam has gotten really out of hand. So we really need these gateways. Now, continuing with my little list here, guys, we also have content filters. A lot of these fancy firewalls have content filters. So it's not just a matter of me going into the firewall and say, okay, you know what, I'm going to block you from accessing YouTube. I'm going to block you from accessing Facebook. No, it's not just that simple. I'm going to go in there and say, you know what, let's block all social media. And it's going to block all and any forms of social media. I bet you there's lots and lots of social media out there that you've never even heard of, that you did not even know exists. And even if it is something that you are aware of, let's say it is Facebook. It's not as simple as, hey, let's go and block Facebook. No, guys. If you actually go into the firewall and you go and tick something, let's say like Facebook, you'll see it's like 8 to 20 different things that it's going to go and block. Things you might never have known that actually exist in the background and that's taking place in the background. So it's not as simple as, hey, let's just go and block Facebook. No. So by clicking a category like social media, you will block everything about every social media website. And if you really legitimately need something to be allowed, something specific perhaps like YouTube, you can specifically go and add an exception for that, and that will of course still work for your organization. Other cool network security functions, and this is really cool, I really love this, is data leak or loss prevention systems. Now the main one I've seen companies use is DLP, data loss prevention. Now, that is usually going to come forth in the form of a policy, but this could also be other things. So I think one of the most common places I've seen this personally, and you do get this in a lot of places, guys, is on 365. So if you go look at Microsoft 365, depending on the license you hold, your company holds, and the users and all that, you could potentially have DLP policies. This allows your company or your client's company to go and scan for things in the whole company environment, things that are not allowed to be shared outside the company or not allowed to be leaked outside the company. Whether it be an accident, whether it be malicious, either way, it's going to prevent that. So imagine for a moment you have only one employee. Imagine this person is sitting right next to you and you can even see on their computer screen. Can you honestly tell me that you can keep an eye on this person every day, the whole day, and prevent them from sharing stuff outside the company? Would it be an accident? Would it be on purpose? But prevent them from sharing stuff outside the company they're not supposed to? Absolutely not. There's no way you can do that. Obviously, you're going to go for smoke breaks, restroom breaks, lunch breaks, and let's not forget you've got your own work and you've got your own life here. There's no way you can keep an eye on that person. Now, if you can't even keep an eye on one person, How do you expect to do that for a company that consists of a couple of hundred or a couple of thousand users? How do you think we're going to go and block them from sharing stuff outside the company they're not supposed to? Now, guys, there's many ways you can tackle that problem. One of those many ways would be the DLP I'm talking about. You get to specify what we call conditions, and you get to specify what we call actions. A condition is a condition that needs to be met for an action to kick in. So I can go and, for example, say, you know what? Nobody in my company is allowed to share credit card numbers, or at least not outside the company. So if one of my employees shares it via email with another employee inside the company, nothing happens because a condition has not been met yet. But should somebody try and share that credit card number via some sort of means with somebody outside the company, that would be a condition that's now met. And if a condition is met, an action kicks in. The action is whatever you specified it to be. This could be honestly just to display a nice assertive scary message that says, please don't do this again. You're in violation of one or more DLP policies, and these are the ones you're in violation of. Some companies will do that because they see this as educating the users. Or it can outright block the person even from sharing this content. So at the end of the day, I'm actually more in favor of just outright blocking people. You know, what's the worst that's going to happen from that? They're just going to moan and groan that they can't share stuff. But if something were to accidentally get leaked, that's a problem, guys. So these, spam gateways and all this is also referred to as unified threat management. It's all in one place on one device, which is usually going to be something like a firewall. So under unified threat management, we can say it's a single appliance or gateway that performs multiple security functions. It's not just a firewall like in the old days. It's got content filtering, it's got antivirus built into it, IDS, IPS, DLP, all of that. Really cool, right? Let's move on to something called legacy systems. Now, if you don't know what the word legacy means in IT, it normally means something is old. This can be old hardware, it can be old software, it can be an old operating system. And generally, like you would expect, if something is old, it can be quite hard to fix it and support it and maintain it. Now, folks, with that thought in mind, if we say legacy systems, this could potentially be when a vendor is no longer active. So this could be maybe for a software, like I said, could be for a lot of things. It can also potentially be that the product that we'll be talking about is depreciated and the vendor has reached its end of life. So this could maybe be an old server that's 20 years old and now you need to go and fix it, but there's no spare parts for this server anymore. So that's a bit of a problem. It can be a very old software that some company is running, and now when it comes to fixing it, there's no support for it anymore. There's just no support system at all. There's no contact us you can go and contact because that vendor or that company is now closed in the meantime. There's maybe no updates for this program or this operating system anymore. There's going to be no newer version for it anymore. And that really throws a spanner in the works in the sense of troubleshooting. So there's been so many times in my life where I've come across old hardware, old software, and I can't fix it because maybe it's just before my time. I just have no idea what I'm doing when it comes to that because it's just before my time. I'm literally going to have to go and find someone older than me that used to work on those systems to be able to fix that. And that's assuming we don't need spare parts or something along those lines, because if it's physical hardware, and great, I might find somebody to help me with this now. If it's physical hardware and we end up needing some spare parts, that could be a problem because we are probably not going to be able to find those old parts anymore. If it's perhaps a very old operating system, that would be a legacy operating system then. And it means the people that designed it or made it, like Microsoft, for example, they no longer support it. So if you look at Microsoft operating systems, currently at the date of this recording, Windows 10 and Windows 11 is still supported for now. Now, Microsoft has announced that they will stop support for Windows 10 on October 2025, but it's fair to assume that they might kick that can down the road again. Microsoft's been known to do that. But if they do stop support for Windows 10 on October 2025, assuming now they do, that would mean after that date, Windows 10 would actually be considered legacy. It doesn't mean you can't use it. You can absolutely still go and use Windows 10 and all the other previous operating systems before Windows 10. So you can still go and install Windows 8, Windows 7, Windows XP, all of those. You can still go and install them. You can still go and use them. Nobody's going to stop you from doing that. But you will not have support. There's going to be no updates, no patches, no security fixes. So if you or somebody discovers some sort of new vulnerability that's never been detected before, tough bananas. There's going to be no update for that. So it's a bit of a problem. That is why you will find that whenever an operating system like Windows 10, whenever it's about to reach its end of life, all companies will then quickly, very quickly actually, in fact, switch over to the next operating system, which in this case is going to be Windows 11. It's not necessarily that they want to. It's not necessarily that they like Windows 11. I'm not saying that they don't. But it's a matter of they have to, because they've got what we call security auditors and all kinds of stuff like that. And if they don't have the latest operating system that's still being supported, that's going to become a problem when it comes to audits. Anyway, so what we can also say with regards to legacy systems, folks, is there's a lack of support. Something I did kind of cover indirectly earlier. So if you look at something, once again, like, Windows 10 or older than Windows 10 specifically, there's going to be no support for it. So yes, Windows is still around, or Microsoft's still there, but they do not support those old operating systems that are older than Windows 10. They don't. They're just going to shrug their shoulders and say, tough bananas. We don't support that anymore. It's old, it's outdated, it's legacy. And the same concept actually applies to software and hardware. So if you go buy yourself, as an example, I'm going to grab a totally random example here, guys. Let's say you buy yourself a washing machine or a fridge or a TV. Now, if you buy it right now and something breaks in it or something goes wrong in the next year or so, chances are they'll be able to fix it for you because it's still relatively new. They're going to have spare parts for it. They still support it. But if you wait, these days it's crazy. If you wait only like 2 years or 5 years, which is not a very long time actually. If you wait just 2 or 5 years, they're going to shrug their shoulders and say, nope, this TV's too old. This washing machine's too old. We don't have spare parts for it anymore. We don't make those parts anymore. You're going to have to buy yourself a new one. It's gotten that bad. So 10, 20 years ago, if you bought yourself an appliance in your home, you could probably keep that sucker for 10, 20 years and you'll still be able to find spare parts for it. People will still be able to fix it for you. Nowadays, it's gotten so bad that if something is older than a year, chances are that manufacturer is no longer supporting that appliance. They're no longer making parts for that appliance. They're just going to shrug their shoulders and say, tough bananas, get a new one. It's gotten bad, folks. Now, something I want to mention, which is pretty obvious actually, if you have old legacy systems, operating systems, softwares and stuff like that, which is no longer supported, it's a risk. I mean, never mind security auditors being on your case, it's going to be a risk. So if these systems don't have the latest updates or patches and stuff installed, it's a huge risk. Security auditors have an issue with this for obvious reasons. So it could be that there's new security vulnerabilities that's just been discovered in your Windows that you're running on your machine, but since you're no longer getting updates, people could potentially take advantage of that if they know about that. So it's a problem, as you can imagine. All right, folks, before we move on to the next topic here, I'm going to play a bit of a game with you guys. Most of you guys know what game this is. So normally in my videos, somewhere there's going to be a hidden word or a hidden phrase I'm going to give you guys. And the idea here is for you to go and make a new sentence using this word or phrase. I mean, you can, of course, go and use it as is in the comment section down below, but there's no fun in that. So it's going to be way more fun. It's going to be hilarious if you can go make a sentence down below in the comment section using the word or phrase I give you. And the idea here is it just causes confusion of anybody that's just, scrolling through the comment section and didn't actually watch the video. So if somebody, for example, didn't watch the video or they only watched the first 5 minutes and they keep seeing you guys using this random word or talking about this random topic, they're going to be very confused about it, especially if it's got nothing to do with IT. And it's a bit of an inside joke between me and you guys. So only people that's watched the video up until this point will know what it's about. Now, this does not stop you from leaving normal comments. So if you've got a normal comment you want to leave, if you've got a question you want to ask, by all means, guys, down below, leave your question down below, and I will gladly get back to you as quickly as possible. Anyway, so today's hidden word or phrase is fish cakes. Totally random. Let's see how creative you guys can be. Make a new sentence using the word fish cakes, but remember, stick to YouTube's rules. So don't go and swear or anything like that. We don't want the YouTube popo on our case. So let's see who can come up with the most creative sentence using the word fish cakes. All right. Anyway, moving you folks on to the next topic here in this section, Internet of Things, better known as IoT for short. Now, I'm not sure if you guys are aware, but this is actually everywhere around us these days. It's really crazy how much this is actually around us, and the average person just doesn't know it. So if you, for example, go to, let's say, an ATM where you go and withdraw money, deposit money, that operating system running on that ATM in a lot of cases is actually IoT, guys. If you have smart appliances in your home, let's say you've got one of those fancy fridges that's got a screen on it that can go online and you can watch TV on it and stuff, that, guys, is Internet of Things. If you've got one of those smart homes where you can go and open and close the blinds, dim the lights or turn them on and off using, something in your house like your phone or remote, that is IoT. You get these fancy smart sound systems as well, smart speakers. So let me add that there for you guys. You get these smart speakers as well you can go and connect to. This could be a smartphone app or a web management app that you're going to go and use to control all this stuff. So you can go and use an app, or you can go and use your PC, log into some sort of web interface, and from there you can go and control whatever it is that we were trying to control here. Guys, this can even be a pacemaker. So you get things in all the categories. You get things in the industrial area, you get things in the medical area, you get things in the tech industry. It's all over. So if you look at something like in the medical industry, this could be something like a pacemaker, which gives the doctor the ability to go and make adjustments to your pacemaker if need be. If you look at the industrial section, this could be those robots and stuff you find in factories. A lot of those robots actually have IoT operating systems on them, and it allows them to be configured and controlled and managed and all that kinds of stuff. So if you go look at the infotainment system in your car, that is very often, depending on the car you've got, IoT, guys. It is freaking everywhere. So if IoT, we can say these are smart device functions. It's kind of like a computer. It's maybe just a little bit more dumber than a computer, but it's right on the edge of just being a full-blown computer. So if we look at that earlier example I gave you guys of smart homes, this could be, like I said, your lights. You can go and turn them on and off. You can go and dim them. You can go and open and close your curtains. Could be a fridge, could be a TV. I think TVs are probably a very good example. Most of us these days have smart TVs. That's kind of sort of IoT, believe it or not. Anyway, folks, so we've now reached the end of the second main section of this module. Let me take you to the third and the last main section of this module, Troubleshoot networks. So I'm going to start you guys off with troubleshooting wired connectivity. So that's specifically a network that specifically works with cables. So this will be your normal LAN cables, potentially fiber cables, maybe coaxial cables, but it's predominantly going to be LAN cables. So Cat5, Cat5e, Cat6, Cat6a, those kinds of cables. So when it comes to troubleshooting these wired connectivities, the first thing you need to do here, folks, is identify the problem. So it's kind of, like we're using those troubleshooting steps from the troubleshooting methodology, except we're not really going to go and use all 6 of them. We're going to use about 3 of those troubleshooting methodology steps. So we need to go and identify the problem. So if somebody moans and groans and says, I don't have internet, or my connection is off, how can we identify the problem? By asking questions. That's one way to do it. It's not the only way. So you can go and ask them questions like, when did the problem start? Did it start today, yesterday? If it was today, when today? You can go and ask them questions like, did you change anything recently on your machine? It could be that maybe they changed the setting. Maybe they changed their IP address. Maybe they installed or uninstalled something on a machine that's basically messing up their settings. You never know. So ask the user questions, assuming you've got access to the user and assuming they're the cause of this. Ask them questions. Sometimes by asking questions, you can actually figure out what the problem is without having to do any troubleshooting. Now, once you've asked your questions or done whatever it is you're going to go and do to go and hopefully identify the problem, you are going to go and establish a theory. So if the user, for example, says, oh yeah, I was busy playing with my IP address settings because I was trying to install a game and this game needs a static IP address, for a server that I have to host on my PC, blah, blah, blah. So what I'm hearing here in this scenario is the user is telling me they fiddled with the IP address settings. Now, great, their game might have worked, but what they might have done now in the process is they might have messed up the IP settings in such a way to the point where they no longer have internet access. I'm just throwing some bones here, guys. So that's my theory. It's not to say that it's true, but it's my theory. So now I need to go and test my theory. So that brings me to the next step, testing my theory. So now I'm going to go onto the person's machine. I'm going to go and check their IP address settings, and I'm going to see, okay, you know what? This person did end up changing their settings. The settings does not look correct. It's not going to allow the individual to access the internet. So these are just some examples, guys. So that's 3 steps. That's pretty much the only steps we're going to discuss with regards to wired connectivity. But yes, in reality, there are 6 troubleshooting steps in the troubleshooting methodology. But with wired connectivity, these 3 are generally enough. Anyway, let me take you guys over to the wireless side of things. We just spoke about wired issues. Let's talk about troubleshooting wireless issues. So first of all, verify the configuration, guys. It could be that this person that's not able to, connect to the Wi-Fi or doesn't have a Wi-Fi connection. It could honestly be that they are, just on the wrong Wi-Fi. It happens. People connect to the wrong Wi-Fi. It could be that there's no password. It could be that it's an evil twin. If you guys know what an evil twin is, someone is tricking this user into connecting to the wrong network. It looks like the real network. It behaves like the real network, but it's not the real network. So check the configuration of that machine. Make sure they're actually connected to the Wi-Fi. Make sure they're connected to the right Wi-Fi. Make sure they're in range of the Wi-Fi. And, check other things like that as well. So in terms of verifying the Wi-Fi configuration, you can go and check things like the name and the SSID. That's pretty much the same thing. So if you guys don't know what the SSID is, the SSID is the name of any Wi-Fi. It is what we use to identify that Wi-Fi connection with. So if you are in my building might be called BurningIceTech. So the Wi-Fi might be called BurningIceTech Wi-Fi. Or if you're in my lobby or my guest lobby, it might be called BurningIceTech Guest Wi-Fi, something along those lines. So that is the SSID. You can make it whatever you want. There's no rule that says you can't use certain names. You can, honest to goodness, use any name you want for the SSID, but generally it's recommended you use something user-friendly and professional that helps you and other people around it identify who this network belongs to or what it belongs to. Now, also in the category of verifying configuration, something you can potentially go and look at is verifying support for Wi-Fi, or should I say 802.11 standard. It could be that this device just does not support Wi-Fi, or maybe the frequency you're trying to connect to, it doesn't support that. So if you go look at the wireless standards, guys, because they all end with 802.11 something, maybe this laptop or this phone or this tablet or whatever it is, maybe it only supports 802.11g, which is one of the most common standards you get. But now you're trying to connect this person, or this person is trying to connect to an 802.11a. It's a different frequency. It's a different standard. It is possible, especially with older devices, that it does not support that standard. So you might want to go and check that what standard are they trying to connect to, and does that device support that standard? It could be that it's a compatibility issue. Something else you might want to go and check, which is less likely, is to go and check for low RF frequency strength. So it is very possible that maybe the signal strength is just low. It does happen. So if someone's sitting far enough away from an access point or a router and they're trying to connect to it wirelessly, it is very possible the signal is just too weak. Sometimes it just won't connect at all, or it'll be spotty in some cases. It'll connect and then disconnect and connect and disconnect and be a bit slow and non-responsive. So those are all symptoms of a low frequency or the strength being weak. So there's multiple ways around that, but that's not the topic here right now. So the easiest and the quickest solution would just be to move this person closer to the access point. If that's not possible, then maybe you can go look at installing additional access points to extend your range. You even get what we call extenders, which is like a mini version of an access point. So you can go look at that as well. Lastly, folks, you can also go and check for wireless signal issue. Now, what do I mean by that? You might think, well, you just said wireless signal strength. I'm not talking about the strength. I'm talking about a conflict in signals. It sometimes happens, guys, that in a building, especially in large office buildings, we've got multiple things broadcasting on the same frequency, and that causes what we call interference. There's a lot of things running on the 2.4 gigahertz frequency, which is the most common frequency. So if we can look at the standard office Wi-Fi, guys, that standard is 802.11g in most cases. Now, the 802.11g standard, along with many others, they all run on 2.4 gigahertz. There's many of them that run on 2.4. 2.4 gigahertz, guys, is the most common frequency out there. You'll find it, cordless phones work on that frequency, baby monitors work on that frequency, radio control cars work on that frequency. Hell, if you go and turn on your microwave oven, it runs on that frequency. There are so many things out there that run on that frequency. So if you've got multiple things in close proximity to one another that runs on the same frequency, that could potentially cause interference. Now, besides changing to a different standard, like maybe changing to 802.11a, which runs at a 5 gigahertz frequency, besides having to go to a drastic measure like that, you could go look at changing channels. Now, in terms of wireless, guys, there's normally 11 channels you can go and choose between. So you can go anything between channel 1 all the way up to channel 11. Now, all of these channels, well, at least most of them, to a certain extent, do ever so slightly overlap with one another. But out of those 11 channels, there's 3 specific channels that's got 0% interference with one another. Absolutely 0% overlap. And those specific channels, guys, is channel 1, channel 6, and channel 11. Make sure you remember those numbers. 1, 6, and 11. That is very, very often asked in the exam. Not only do they ask you that in the A+ exam, but if any of you guys plan on taking the Network Plus exam, I can guarantee you that will be in the Network Plus exam as well. So they want to see and test and check if you know that 1, 6, and 11 are the only channels that's got 0% overlap between one another. So not only is this a theory question exam, it's actually part of a PBQ in the exam. I'm not saying you will get this PBQ. You might not. But there is a PBQ in the exam where you have to go and configure 3 different access points, and you have to make sure they do not interfere with one another. And what you need to do is, on the one access point, you need to go and choose channel 1. On the second one, you need to go and choose channel 6. And then, of course, on the third channel, you need to go and choose channel 11. Now, it doesn't matter which one of these 3 access points you make channel 1 and which one you make channel 6 and which one you make channel 11. As long as all 3 of them are on those 3 channels, different ones, you're good to go. And then the very last, very quick briefing I want to mention before I move you guys on to one of the last topics in this module is assess environment for interference issues. Now, I did accidentally give you guys that earlier, so this could actually potentially be something like a microwave oven. I kid you not. So microwave ovens is obviously not a wireless device we normally go and use, but they do emit a frequency of 2.4 gigahertz. Not when it's plugged in, not when the screen is on, but once you actually heat something up in it, then it emits a 2.4 gigahertz frequency. So if you've got people, let's say, complaining that every day in lunchtime, the Wi-Fi goes off and on and off and on, and specifically at lunchtime, maybe just go check if they don't have a microwave oven near the router or the access point or the device that's supposed to receive the signal. It could be that it's causing interference on the signal, depending on where this microwave oven is located. Yeah, I know, it's the weirdest thing, but it happens. All right, folks, I'm going to move you on to the last topic in this module. Can you believe it? So the last topic, guys, is called Troubleshoot Limited Connectivity. Now, the best example of this that you guys might have seen already in your life is on your laptop or your desktop at the bottom right next to your system clock. Normally where you'll see the little Wi-Fi icon or the little computer icon that shows you that you are plugged into a network cable or that you're connected to a Wi-Fi connection, there you might sometimes see a little yellow exclamation mark. And if you hover your mouse cursor over it, you'll see it says something along the lines of limited connectivity or no internet. Now this can unfortunately obviously be caused by many things. It could be that the cable is faulty, misconfigured, broken. It could be that the port that the cable is plugged into your laptop or desktop is damaged. It could be the port on the switch or the router that the cable is plugged in that's damaged. It could be that you're just out of range of the Wi-Fi signal if you're using Wi-Fi. It could be that maybe your machine does not have an IP address. Maybe the DHCP ran out of IP addresses. It could be that maybe you've got a static IP, but the static IP is configured incorrectly. It can be so many things. Now, because of how big this list of things could be, of what it could possibly be, it's sometimes a bit overwhelming in a sense of where do I even start when it comes to troubleshooting? People don't even know where to start. It could be a case, for example, of the physical link is operational. So physically the cable is perfectly fine, or physically your machine is connected to the Wi-Fi, but the IP configuration is for some weird reason faulty. Now you're sitting here scratching your head, wondering, okay, but what's wrong with my IP configuration? Other things you might see is sometimes your IP address will be on dynamic, and when your machine is on dynamic, in other words, it's getting an IP from a DHCP, your IP would actually be 169.254.something.something. That is called a PIPA. Now, people always laugh when I say it like that because apparently the way I pronounce it is weird. I think it depends on the language you speak and which country you're from. But at the end of the day, 169.254 refers to the fact that you do not actually have an IP. So you can think of that number as a placeholder of sorts. So if your device, whatever device this might be, if it's on dynamic, if it's supposed to get an IP on a network automatically, which is the case for most devices, and it's unable to get one automatically, then it gets what we call an IP path. Why it gets that could be for many reasons. It could literally just be the cable's unplugged, could be that the Wi-Fi is disconnected, maybe the IP addresses ran out or the signal is weak. It can be for many, many reasons, but it's up to you to figure out why that is. Now, if you or this person have a static IP address and the connection is dead, then it gets a little bit more tricky. Now you have to go and check, is that IP address in the correct range? It could be that you or the previous person misconfigured this IP address in the wrong range, and that's why they're not communicating with one another. Now, in terms of, troubleshooting this connectivity issue, sometimes a good place to start would be to try and establish the scope of the network problem. In other words, how big is this problem? How far does it stretch? Is it affecting a single host or a single switch or router? Or is it affecting multiple people, multiple devices, and multiple switches and routers? So try and see if you can figure out how many people and devices this is affecting and which people and devices is affecting. So once you figure out the scope, then that's going to obviously, make your list a lot shorter in terms of where to go and troubleshoot and what to go and check for. So if it's only affecting one single host, it could be that maybe it's just that specific network cable between that host and that switch or router. It could be the port on the laptop or the desktop that the cable is plugged into. If this cable is plugged into a switch or a router, it could be that that specific port on the switch or router is faulty. It could be that this host is maybe on the wrong VLAN. It's not the port that's faulty. It could just be that they plugged into the wrong port on that switch. Depending on which port you're plugged into, you'll be on the wrong VLAN, or you could be on the right VLAN. So it's important to check that you are plugged into the right port on a switch as well, if you know how VLANs work. Something else to go and check is, can this host perhaps access local network, but not the internet? So if they can still access the local network, their colleagues and the servers and stuff, but just not the internet, then okay, it's not the Wi-Fi, it's not the cable, because if the Wi-Fi or the cable was the issue, then obviously you would not be able to do that either. So it might be a setting related to the internet. Possibly the default gateway IP address has maybe been misconfigured, you never know. It could just be that there's no gateway specified, or maybe it's the wrong gateway that's been specified. Lastly, folks, before we conclude this, verify which network this host is in. So this device that's having the issues, whether it be a laptop or a tablet or a phone or a desktop, it's probably going to be a laptop or a desktop. Check what network it is in, and then go and check in which network it's supposed to be in. Sometimes this actually happens more often than I would like to say. Sometimes it happens that this machine is just in the wrong network. It could be that it's on the wrong subnet. It could be that it's on the wrong VLAN. It could be that it's plugged into the wrong switch port. You never know. So make sure the connection is correct on the switch or the switch port. And then also go and check the VLAN settings. So in terms of switch port configuration, make sure this machine is on the correct VLAN and not the wrong VLAN. You might have to go and plug the cable out and plug it into a different port, or you might have to go and log into the switch and change the VLAN for that specific port. All right, folks, so we have finally reached the end of Module 7. Whew, that was a lot. So I hope you guys have enjoyed this. I hope you guys have learned something from this module. If you have, do me a favor, give the video a like. I really would appreciate it if you guys do that. If you'd like to know when Module 8 comes out, or more practice questions or anything like that, maybe consider subscribing. Otherwise, you might miss it. And then lastly, before we conclude this video, a quick thank you and a shout out to all of you supporting this channel and sponsoring the channel. So for those of you just clicking on the thanks button below the video, if it's available in your country, for those of you buying me coffee and milkshake, for those of you doing PayPal donations and the Patreons. By the way, if you want to support the channel, you can do that in the video description down below. So just check the video description down below. There's all the links that you can go and follow if you want to go and just donate a coffee, or become a Patreon or do a PayPal donation, whatever. Those links are down below. So as for PayPal donors, thank you very much, guys. There's a list of some of the guys. So thank you very much, guys, for doing those donations. And then the Patreons. Oh, goodness. There is so many Patreons. Unfortunately, the majority of them prefer to stay anonymous. So if you do become a paid Patreon, I will normally ask you if you would like to be on this list. Or you can just ask me yourself, if you beat me to it. Either way, you can be on this list. I would normally ask you what name you want to have displayed. So if you are a paid Patreon. Alternatively, you can remain anonymous like most people prefer to do. So it's really your choice. And then the very last thing, guys, I'm sure you guys know it. The channel does have a Discord server. So if you'd like to join a community of like-minded people, possibly be in a study group or ask questions if you're getting stuck or help other people that's getting stuck of A+ or otherwise, there's a free Discord server. It's called Free IT Training, and the link is in the video description down below. It's literally the very last link in the video description. All right, folks, I will see you in Module 8 of the CompTIA A+ course.